Well, good morning. Lessons 41 through 43 of Saxon Algebra 1. These lessons are focused on primarily one deal, and that one deal is that if you have a complicated number that you're adding to another complicated number, and it looks like gibberish to you, how do you make sense of it? So the goal here is to take what we've already learned this year and to put it into practice when something looks like gibberish. And so let's start with the not look like gibberish concept on lesson 40. The concept you've done a billion times, and that would be something like if you had 1/3 plus 1/4. Okay, the concept is you can only add things that simply if the denominators are the same. In other words, you can't just add them like this easily. You have to do stuff and make denominators the same. In this case, you would say, okay, 12 is my denominator by multiplying top and bottom by 4 and the top and bottom by 3. You end up with 4/12 plus 3/12. And your answer would be 7/12. Okay, so that's not that complicated what you're dealing with. Okay, second piece of this, you're saying, well, what if I have a plus 2a? Well, these are the same. I think 1 apple plus 2 apples is going to give me, that's right, 3 apples. Well, what if I have a plus 2a minus 3b? What is that? Well, I have an apple plus 2 apples minus 3 bananas. You can't, on paper or in your head, squish, unless you have a blender, an apple and a banana together. So your answer to this one would be to simplify this one. In other words, it's 3a minus 3b. So that's your 3a. Only the things that look the same, that are the same, can be added together. And this number in front, this 2, just tells you how many of these things there are. Okay, these things, to use math, are called terms. Okay, the number in front of them are called coefficients. So we have -3 of whatever those are. We have +2 of whatever those are. We have 1 of whatever that is. Okay, it's just a thing. Okay, all right, so that's the second thing. So first thing is a reminder of you've got to remember how to add fractions. Second is you can only add like terms. Third concept is understanding that if you have something like this, and you say, okay, what is that? Understanding that a negative exponent just means that if you put it on the other side of a fraction, it becomes a positive exponent. Same way, you could have something like a squared b to the -4 over c to the -3. Well, this would be a squared, and this one becomes b to the 4th on the bottom. This one becomes c to the 3rd on the top. So a negative exponent, if it's on the bottom, gets moved to the top, and a negative exponent, if on the top, gets moved to the bottom. Okay, so now we're going to take these three and then put them together into a complicated looking problem and see how that is done. So let's go to lesson 41 and 42. Okay, so let's start with something like this. If you have a question, and you will have these, where you'll say, okay, bx over x to the 3rd y to the -2 minus 3by squared x to the -2 plus 4y squared over bx squared. It's a b. All right, first of all, your question is like, how did that come up with? Who cares what that is? Again, algebra is just representing things. In math, in science, it is very common to have equations looking just like this. And so you're going to have to figure information based on the equations that you have. Well, to do that, you must recognize, well, complicated things can sometimes be made simpler. So we're going to, we're going to start with that concept. We're going to say, okay, let's see if we can simplify this as much as possible. And first of all, I don't even recognize what this stuff is. So let's start with this first one. Can I simplify that? Well, I have an x on top and an x3. Well, actually, let's start with this. B is a b. Not going to change it. I have an x on the top, but I have 3 x's on the bottom. Remember, x to the third is x times x times x. Well, one of those x's will cancel, and I'll end up with an x squared on the bottom. And then I have a y to the negative 2. I'm going to put that on the top. So this is kind of the simplest version. There's no negative exponents. There's no duplicate things like the x's here. There's each of the terms that are in here are just what they are. Okay, now I'm going to say minus 3. Okay, that's not going to change. B is not going to change. Y squared is not going to change. And x to the minus 2 is an x squared on the bottom. So now you want to notice I have a b y squared x, a b y squared x. Remember, these are the terms, sorry, and that is the coefficient. So I have one of these minus 3 of those. Okay, so this is whatever those are. Those are the, and let's see if the last one makes any difference. And I have a 4y squared bx squared. Okay, so does that look like these guys? Well, it's close. There's a y squared on the top and x squared on the bottom, but the b is in the wrong spot. That means it's different. So I have one of these minus 3 of these. Well, that's negative 2. Negative 2 of these. That's b y squared over x squared. Plus, I have 4 y squareds over b x squared. That's as good as you get. And so this thing here, I can be assured that the simplest can get here by going a couple of steps. One, simplifying each term and then see if they look the same. And if they are, boom, I just do it. If they aren't, fine. That's what this lesson is about, is basically this concept. So let's look at some of the problems you might have on your homework. This is probably more complicated than you would see on any of your homework questions, but it's not that far removed. So here we go. This is practice problem A. Practice problem A. X to the minus 2y plus 3y over x squared minus 5xy. And the question is, simplify by adding like terms and write the answers with all variables in the numerator. That's a fourth step, which we didn't do before, but we'll start with simplifying them. So, okay, so this one is x to the minus 2y. Okay, I'm going to make this y over x squared. This one is going to be plus 3. I'm going to put the number in front, y over x squared, minus 5xy. So there's one of these, 3 of these, and they're the same. So it's going to be 4 of these, and minus 5 of these. Now the instructions here say write them with everything in the numerator, all the variables in the numerator. That is for this problem. It's asking you to do that. Many problems it won't. So we're just going to go ahead and do that for y, and that's x to the minus 2 minus 5xy. That's it. That's as simple as it gets. Again, most of the time we leave it like this, where everything is positive, no negative exponents. In this case, the question in the homework saying, hey, put the negative exponents in there. And they're doing that just to help you get used to seeing them there and be able to go both directions, both from here to here and then from here to here. Okay, let's give you another problem. This one a little bit more complicated. This is practice problem B. Similar to this first one, this should make more sense to you now. So I have a to the minus 8th b squared over b to the minus 9th minus 4b to the 11th over a to the 8th plus 6b to the 11th over a to the 8th, b to the 5th. Okay, complicated. Let's make them all without negative exponents. So starting with the first one, a to the minus 8 is a to the 8 on the bottom. Okay, that's that one. I have a b to the minus 9. Well, that would be a b to the 9th on the top. And then I have a b squared and a b to the 9th, so that's going to be to the 11th. So I can take that first one and make it look like this. Minus 4. Again, put the number out front. That helps. B to the 11th over a to the 8th. So I have essentially one of those minus 4 of those because they're the same. Let's see if the last one is the same. And I'm going to put the 6 out front. And let's see what I can do. I have a b to the 11th and a b to the 5th. Well, that's going to be a b to the 6th. And a to the 8th on the bottom. Well, this one is very different than these two. So this is 1 minus 4 is negative 3 of those, b to the 11th over a to the 8th, plus 6, b to the 6th over a to the 8th. That's the answer. Not much else you can do with it. Now, this problem says show them with all the variables in the numerator, so that's going to be minus 3b to the 11th, and I'm going to throw that 8 up top, plus 6b to the 6th, and throw the a up top. And that's the answer. So first step is get them all clean and reduced. Second step, do any adding or subtracting that you need to. And then in this case, that's usually where you're done on these problems. But the third step, it says, okay, anything in the denominator, throw into the numerator and make them have negative exponents. That's pretty much it. Okay. One other issue that comes up with lesson number 41 should not be complicated, should be fairly easy for you to spot, is, and it seems like it's not related, but ultimately it will be, is they're saying, okay, let's say x plus 7 equals 2. This is actually practice problem C from your homework. And, okay, what's x? Well, subtract 7 from both sides, and I get x equals negative 5. Okay, there's this. But the question is, if this is true, then what is x plus 3? Okay, well, if this is true, that means x has to be negative 5. So what is x plus 3? Well, that's negative 5 plus 3, or negative 2. So it's just really a two-step problem. It's using a if this is true, then, or what, then. It's kind of this concept of we use in math called if then. If this is true, then what? Well, in this case, if this is true, then what is x plus 3? So you just figure out what makes this true, then logically you put that number into here and it'll tell you the answer. So you have a couple of problems like that on lesson number 41, and that's that. That's lesson 41. Lesson 42 is talking about what we would call multiple or multivariable equations. So what does that mean? Up till now, we've been saying things like x plus 2 equals 7. What is x? And you go, well, x is equal to 5. That's called a single variable equation because there's only one variable in it. You're only solving for one. Well, there's relationships sometimes where there's more than one variable, and we will be getting into that in great detail this year, but this is kind of the beginning of this concept. So when we say if there's two things, so let's say, for example, we have 6y minus x plus z equals 4. Well, there's three variables. There's y's, there's x's, and there's z's. They're all different. They're different terms. And then you also have numbers in here. And so you can't just say x is equal to 4, you know, or 10 or 100. X depends on what y and z are. And so what you're looking for when you're saying, and you will see this, and you'll say solve this for a variable. In this case, I'm going to solve this for y. What that means is I want y equals something. And it'll have x's and z's and numbers in it. Okay, so how do we do that? Well, we start with isolating the 6y. Let's start here. I'm going to get rid of this stuff. Sorry. Let's try it this way. There we go. We'll solve for y using this equation. So I've got 6y, and I'm going to put equals. Right now the equal sign's way over here. Well, I know there's a 4 on that side. So again, balanced scale concept. I have a negative x on the left side. If I add x to both sides, this goes away. If I subtract z from both sides, this one goes away. And then I have a positive 4 on that side. So I can simply isolate the one I want and then move everything else over to the other side. Okay, when I'm done here, what's going to make this a y? Well, or a 1y, well, if I divide 6 by 6, that's 1. So I do it to the left, I do it to the right. And so y equals that. Okay, let me do it one more time, because that may have been a little confusing for you, seeing it for the first time. So let's look at it another way. Let's pick a problem like this one. 4x minus 2y plus 2 equals y minus 4. And I want to solve for, I'll pick y again. All right, so ultimately my goal is y equals something. All right, well, let's start with, where are the y's? I've got y here and I got a y here. I want them on the left, so how do I get rid of this one? Subtract y from both sides. Okay, so now I have negative 3y on the left. Okay, those go away. And negative 2y minus y is negative 3y. I have a 2 on the left. Well, I'm going to put it on the, I don't want it on the left, so if I add 2 to that side, that goes away. Okay, and negative 4 plus 2 is negative 2. That's those. And then I have a 4x. Well, if I subtract 4x from both sides, I get to here. And so now I've got the y's on the left. As a matter of fact, I have negative 3 of those y's. And I have other junk on the right. And everything's been accounted for. Now I'm going to divide both sides by 3, or negative 3. And negative 3 over negative 3 is 1, so I have y equals negative 4x minus 2 over negative 3. And that's the answer. And so that's all we have to do. And so when we are solving for a variable on that has lots of different terms on it, in this case there's numbers, y's, and x's, you first get all the ones you want on one side, and then just continue the math that you already know how to do. And that's lesson number 42. Last lesson, number 43, is going to be about something you've already done before, so you'll go, oh, good, not a lot of new stuff. Because I've been teaching it a certain way, this will be simple. And this is the concept of least common multiple. Okay, what does that mean? So, for example, 3 and 5. What's the least common multiple? Well, that's 15. Okay? In other words, if I were to do 3's, it's 3, 6, 9, 12, 15, 18, 21, 24, etc. 5's is 5, 10, 15, 20, 25, 30, etc. And well, let's keep going here, 27, 30. So notice that 30 is a common multiple, but 15 is the least common multiple. Okay, so how do you find the least common multiple between two numbers? Well, you just kind of can do this list and find it. The simpler thing is you look at just that times that. But what if you have 3 of them? It becomes a little bit different. So let's say we have, 15, 10, and let's pick 4. And we say, what's the least common multiple? Okay, if you remember what we did is we said, okay, this one is 3 times 5 if we prime factor it. This is 2 times 5. And this one is 2 times 2. So the least common multiple, I can make lists like this, but I don't have to. I look at what's common. What do they each one have? Well, this has got a 3, and it's got a 5. This one has a 2 and a 5. That's also there. And this one has a 2 and another 2. So I look at what's common, 3s, and basically to get them all, what do I need? I need a 3, a 5, a 2, a 5, a 2, and a 2. I could just multiply them together, but that may give me a multiple, but not the least common multiple. Least common multiple is I start on the left and I basically, again, say, okay, 3, that's one. A 5, that's another one. Okay, next one. A 2, well, that's new. A 5, well, we already have a 5. Don't need that. So let's look at this. And then a 2, and oops, well, this one's got 2 2s. Well, none of the others have 2 2s, so that's that second 2. Okay, so if I look at this, 3 times 5 is 15, and 2 times 2 is 4, so that's 60. That's my least common multiple, is 60. 3 times 5 times 2 times 2. Okay, let's do it by list. 15, 30, 45, 60, 75, 90. Okay. Then I have 10, 20, 30, 40, 50, 60, 70, etc. And 4s. 4, 8, 12, 16, 20, 24, and eventually I end up at 60. And it turns out that 60 is the least common multiple. And I did it by this cool method. All right, so let's look at one more shot at that and see if that sunk in. Okay, what is the least common multiple of 14, 20, and 30? I do not want to make lists with these. So 2 times 7, 20 is 2 times 10, 10 is 2 times 5, 30 is 3 times 10, which is 2 times 5. So common, okay, I've got a 2, a 7. This has got a 2, got one of those. It's got another 2 and a 5. This one's got a 3. No, we didn't have any 3s. A 2, well, we already got a 2, and we already got a 5. So 2 times 7 is 14. 14 times 2 is 28. 3 times 5 is 15. So 28 times 15, I do 5 times 8 is 40. 2 times 5 is 10. 5 times 14. And then 0 to 8. And 0, 3, sorry, 2, 1 left over, and 4. 420 is the least common multiple. I did not want to make lists to find that. So that's part of the homework. Now let's add a layer of complexity to it that actually is easy because it's letters. Letters you find are a lot easier than numbers. So let's say I have 4a to the third, b to the fourth, and 6a to the 10th, b squared. And I want to find the least common multiple. Well, let's start with the 4 and the 6. 2 times 2 is 4, 2 times 3. So my least common multiple is 2, and another 2. Well, I've already got a 2, so that one's good, times 3. So 2 times 2 is 4, 4 times 3 is 12. Well, you could have thought that 4 and 6, what's the least common multiple? 4, 8, 12, 6, 12. 12 is going to be obvious. Now, if I look at this and I say, okay, what is my least common multiple? Now really what I'm looking at is just which one's the bigger. A, there's 3 of them. There's 10 of them. So there's 10 is the least common. B is 4, the biggest one. That's it. That's the least common multiple of those. Do another one. How about 12x squared am squared? And then I have 14x cubed am to the fourth. Okay, so let's look at this one. Let's start with the 12 and the 14. 12 and 14. 12 is 2 times 6. 6 is 2 times 3. 14 is 2 times 7. So my least common multiple of the 12 and the 14 are going to be, it's going to have a 2 and a 2. That one's already got a 2. It's going to have a 3. And it's going to have a 7. So 4, that's 4. That's 21. 4 times 21 is 84. So that's my least common multiple on the numbers. So it's 84. And I start with my x's. What's my biggest x? X to the third. I've got 1a and 1a, so that's just an a. My biggest m, m to the fourth. That's the answer. So the letters are a lot easier. I just picked the bigger one. And that's going to be the least common multiple. That's lesson 43. And that's your homework for this week. Have a great day.